Okay, so today we will be looking at a problem where we want to determine the stopping distance for a vehicle that is initially traveling at 95 kilometers per hour, and we are given that the human reaction time is 0.4 seconds. Now, before we go any further with this problem, we note that 95 kilometers per hour is not in SI units. So we can convert that and multiply by 1000, then divide by 60 by 60 to give us an answer in meters per second, and this is going to be equal to 26.39 meters per second. Now, we divide our problem into two parts. For the first part, the vehicle is traveling at this constant velocity of 26.39 meters per second for a time interval of 0.4 seconds. For the second part, the vehicle is no longer traveling at a constant velocity, but rather at a velocity that is a function of time for a constant acceleration. And the vehicle will be traveling for t equals tf seconds until it comes to a complete stop. Now, our question is also in two parts. We have the first part where the vehicle is decelerating or accelerating at a negative rate of 3 meters per second, and for the second, this acceleration is negative 6 meters per second. Now, for both of these parts, this x1 given here will be the same, so we can just calculate that first. Now, x1 is going to be equal to our initial velocity of 26.39 meters per second, of course, times 0.4, which is the human reaction time. And this is 10.56 meters, so that is x1. Now, x2 will differ depending on whether we are answering question A or B. So let us answer question A together. Now, the velocity as a function of time is given by the integral of the acceleration over time. We are given that v0 is equal to, once again, 26.39 meters per second, and then our final velocity is 0, since we are dealing with a problem where we are coming to a complete stop. So our velocity as a function of time is going to be the integral of negative 3 meters per second squared over time. This is simply negative 3t plus a constant. Now, this constant is simply found by setting t equal to 0, so it is our initial velocity. So we have the function negative 3t plus 26.39. Now, the time that it takes the vehicle to stop is found at the point where our velocity as a function of time is 0. So we say that 0 is equal to negative 3 tf plus 26.39, and therefore we can find that the time it takes for the vehicle to come to a stop is 8.80 seconds. Now, we want to find the distance. And once again, distance over time is the integral of the velocity over time, which is simply going to be the integral of negative 3t plus 26.39 over time. Now, this integral is equal to negative 3 over 2 t squared plus 26.39t, and in this case the constant is 0 because we are setting our initial distance to 0 for this part of the problem. Now, the distance traveled as we go to tf is simply x, where we substitute in tf. So x2 is equal to negative 3 over 2 times 8.8 seconds squared plus 26.39 times 8.8. This is squared, and that simply gives us 116.07 meters. So, our final stopping distance for A is going to be equal to the first distance that we calculated, which was 10.56 meters. So 10.56 plus 116.07, which is the distance we calculated here. And this gives us a final answer of 126.63 meters. Now, we can repeat this whole process for section B. I'm not going to go through it step by step once more, but it is written out here. So we find this time that we are integrating -6, the constant acceleration. And so this is the function that we get for the final velocity. It's very similar. This time we find that the time to stop is 4.4 seconds. So our distance function is once again very similar, only this time -6 is our acceleration. And so the distance that the vehicle travels before it comes to a stop is 58.04 meters in this case, which means that our final stopping distance is calculated here and given by 68.6 meters.